Hello friends. In the previous video, we learned database sharding. We saw why a single database cannot handle billions of users. We learned how companies split data across multiple databases called shards. But now a very important question appears. Imagine Instagram has hundreds of shards. Your profile is stored somewhere inside one of them. How does Instagram know exactly where your data lives? When you open the Instagram app, how does your request travel through the system? How does it find the correct shard? And what actually happens internally before your profile appears on screen? Today we are going to follow a real request from start to finish. By the end of this video, you will understand how large-scale systems locate user data in milliseconds. Let's begin. User opens Instagram. Imagine you open Instagram right now. You tap your profile icon. For you, it feels simple. Tap. Wait a fraction of a second. Profile appears. Done. But internally, many things happen. Your phone sends a request to Instagram's backend. Now the system needs to answer one important question. Where is this user's data stored? Remember, Instagram does not keep all users inside one giant database anymore. The data is spread across many shards. So before fetching anything, the system must first find the correct shard. Step 1. Request reaches load balancer. The first thing that receives your request is usually a load balancer. Think of it like a traffic controller. Instagram has thousands of backend servers. If every user tried to hit the same server, that server would immediately become overloaded. So the load balancer distributes incoming requests across many backend servers. One request may go to server A, another may go to server B, another may go to server C. This keeps traffic balanced. Suppose your request gets sent to one backend server. Now that server takes responsibility for handling your request. Step 2. Backend looks at your user ID. Every Instagram account has a unique user ID. Let's imagine your user ID is 12345. The backend server receives your request and immediately extracts this user ID. Now the server asks, which shard contains data for user 12345? This is where the real magic begins. Step 3. Shard key. Remember from the previous video, we talked about shard keys. A shard key is simply the value used to decide where data should live. In many systems, the user ID itself becomes the shard key. Now imagine Instagram currently has 4 shards. The system can use a simple formula. User ID modulo number of shards. In our example, 12345 modulo 4. The answer points to one specific shard, maybe shard 1, maybe shard 2. Depends on the calculation. The important thing is this. The system does not search every database. It calculates the location instantly. Within milliseconds, it already knows exactly where your data lives. Step 4. Shard router. In larger systems, there is often a dedicated component responsible for this job. It is called a shard router. Think of it like Google Maps for databases. You provide a user ID. The router tells you exactly which shard to visit. Instead of searching everywhere, the request is sent directly to the correct location. This saves huge amounts of time and resources. Step 5. Before touching the database. Now many beginners think the system immediately queries the database. Not necessarily. Because databases are expensive. Even though they are fast, cache is usually faster. So before touching the database, the system checks cache. If the profile data already exists inside cache, the request can be completed immediately. No database query required, no disk access required. Response returns almost instantly. This situation is called a cache hit. And this is exactly why caching is such a powerful concept in backend engineering. Step 6. Catch miss. But what if the data is not inside cache? This is called a cache miss. Now the backend must fetch data from the database shard. The shard receives the query, looks up the user record, returns the profile information. The backend sends that information back to the user. But before finishing, the system usually stores a copy inside cache. So next time someone requests the same profile, the response becomes much faster. This means the first request may be slower, but future requests become significantly faster. Step 7. Replicas enter the picture. Now another optimization appears. Remember replication from the previous video? We learned that a shard often has multiple copies, one primary, and one or more replicas. Most Instagram actions are reads, viewing profiles, viewing posts, viewing comments, viewing stories. These operations simply read data. Because of this, many systems send read requests to replica databases. This reduces pressure on the primary database. Traffic gets distributed, performance improves, and the system scales much better. Step 8. What about writes? Now suppose you update your bio, or upload a new profile picture, or change your username. This is no longer a read operation. This is a write operation. Writes usually go to the primary shard. The primary database updates the data, then that update gets copied to replica databases. This keeps all copies synchronized, so reads remain fast while data stays consistent. Step 9. What if the primary fails? Now imagine something goes wrong. The primary shard crashes. Maybe hardware fails. Maybe a network issue occurs. Maybe an entire machine goes offline. Does Instagram stop working? Not necessarily, because the system already has replicas. One replica can be promoted to become the new primary. Traffic gets redirected. Operations continue. In many cases, users may not even notice that a failure occurred. This process is called failover, and it is one of the reasons replication is so important in distributed systems. The complete journey. Now let's combine everything. You open Instagram. Request reaches a load balancer. Load balancer selects a backend server. Backend extracts your user ID. Shard router finds the correct shard. Cache is checked. If data exists, response returns immediately. If data does not exist, the shard is queried. Replicas handle reads. Primary handles writes. Response gets generated. And your profile appears on screen. All of this often happens in just a few milliseconds. Pretty amazing when you think about it. Today we learned how large-scale systems actually find your data after sharding. We followed a request from your phone all the way to the correct database shard. We learned about load balancers, shard routers, caches, replicas, primary databases, and failover. But now another important question appears. What happens when the number of shards keeps changing? How does the system still know where your data lives? And how can data be redistributed without breaking everything? That leads us directly into our next topic, consistent hashing. And trust me, that is where distributed systems become even more interesting. Thank you for watching. See you in the next one, where we make hard tech topics easy, actually.